Question 1. What is the primary benefit of using cloud-based text-to-speech (TTS) services compared to traditional methods? Option A. Eliminates the need for any programming knowledge. Option B. Provides highly scalable, managed services leveraging advanced AI for natural-sounding speech without complex infrastructure management. Option C. Guarantees 100% real-time speech synthesis for all text lengths. Option D. Only supports a single, standardized voice across all languages. The correct answer is provides highly scalable, managed services leveraging advanced AI for natural-sounding speech without complex infrastructure management. Here's the explanation. Cloud-based TTS services are highlighted for their scalability, managed nature, use of advanced AI for natural speech, and abstraction of infrastructure complexity, making them superior to traditional methods that would require managing complex infrastructure or developing sophisticated linguistic models. Question 2. A developer wants to customize the pronunciation of a unique brand name and add a specific pause before a word in an application's audio output. Which text-to-speech feature is specifically designed for this purpose? Option A. Neural voices. Option B. Asynchronous synthesis. Option C. Speech synthesis markup language, SSML. Option D. Audio output formats. The correct answer is Speech Synthesis Markup Language, SSML. Here's the explanation. SSML, Speech Synthesis Markup Language, is an XML-based language that allows developers to fine-tune speech output, including pronunciation, pitch, volume, speaking rate, pauses, and emphasis, making it ideal for the described customizations. Question 3. Which of the following best describes the key differentiator and advantage of neural voices, e.g., WaveNet Tacotron 2, in cloud text-to-speech services? Option A. They support a wider variety of audio output formats than standard voices. Option B. They enable asynchronous synthesis for longer texts, reducing real-time processing load. Option C. They produce highly natural, human-like speech with improved prosody, rhythm, stress, intonation, compared to standard voices. Option D. They are significantly cheaper to use than traditional concatenative voices. The correct answer is they produce highly natural, human-like speech with improved prosody, rhythm, stress, intonation, compared to standard voices. Here's the explanation. Neural voices leverage advanced deep learning models to produce highly natural, human-like speech with superior prosody, which is a significant quality differentiator compared to older, more robotic-sounding standard or concatenative voices. While cost can be a factor, superior naturalness is the primary technical advantage. Question 4. Which of the following best describes the comprehensive process of speech translation? Option A. Converting written text from one language to written text in another language. Option B. Converting spoken language into written text in the same language. Option C. Converting spoken language from one source language into another target language, often including synthesized speech output. Option D. Generating natural-sounding speech from written text in a single language. The correct answer is converting spoken language from one source language into another target language, often including synthesized speech output. Here's the explanation. Speech translation is an advanced AI service that enables the conversion of spoken language from one source language into another target language, often in real time, integrating STT, NMT, and optionally TTS. Question 5. Which sequence correctly represents the typical core AI components involved in a full speech-to-speech translation pipeline in a cloud environment? Option A. Text-to-speech, TTS, right-pointing arrow, automatic speech recognition, ASR, right-pointing arrow, neural machine translation, NMT. Option B. Automatic speech recognition, ASR, right pointing arrow neural machine translation, NMT. Right pointing arrow text to speech, TTS. Option C, neural machine translation, NMT. Right pointing arrow. Automatic speech recognition, ASR, right pointing arrow text to speech, TTS. Option D, automatic speech recognition, ASR, right pointing arrow text to speech, TTS. Right pointing arrow neural machine translation, NMT. The correct answer is automatic speech recognition, ASR, right pointing arrow neural machine translation, NMT. Right pointing arrow text to speech, TTS. Here's the explanation. The process begins with ASR converting spoken audio to text, followed by NMT translating that text to the target language, and finally TTS converting the translated text back into spoken audio. Question 6. A company is planning to host an international webinar with participants speaking various languages. They want to provide real-time subtitles that translate the speaker's words into each participant's preferred language. Which cloud AI service is most appropriate for this scenario? Option A, a standalone speech-to-text (STT) service. Option B, a standalone text-to-speech (TTS) service. Option C, an integrated speech translation service. Option D, a natural language understanding (NLU) service. The correct answer is an integrated speech translation service. Here's the explanation. An integrated speech translation service is designed for scenarios like multilingual meetings, providing real-time translation of spoken language via ASR and NMT into text subtitles or synthesized speech for different target languages. Question 7. What is the correct sequence of core components typically involved in processing a user's spoken command by a cloud-based voice assistant? Option A, text-to-speech, TTS, to natural language processing, NLP, to automatic speech recognition, ASR. Option B, automatic speech recognition, ASR, to natural language processing, NLP, to dialogue management to text-to-speech, TTS. Option C, dialogue management to automatic speech recognition, ASR, to text-to-speech, TTS, to natural language processing, NLP. Option D, natural language processing, NLP, to automatic speech recognition, ASR, to dialogue management to text-to-speech, TTS. The correct answer is automatic speech recognition, ASR, to natural language processing, NLP, to dialogue management to text-to-speech, TTS. Here's the explanation. The How It Works section clearly outlines this flow. Automatic speech recognition, ASR, service takes this audio stream and converts it into text. This text is then passed to the natural language understanding, NLU, service. The identified intent and entities are then fed into the dialogue management system. This response is then sent to the text-to-speech, TTS, service. The exam tips also reinforces. Understand the core components. Always remember the fundamental sequence. ASR, speech-to-text, to NLU, intent entity extraction, to dialogue management, logic action, to TTS, text-to-speech. Question 8. Why are serverless functions, e.g. AWS Lambda, Azure functions, Google Cloud functions, often preferred for implementing the back-end logic of cloud-based voice assistants? Option A, they enable local processing of ASR and TTS on the edge device, reducing cloud costs. Option B, they provide persistent, dedicated servers for handling conversational state, ensuring high availability. Option C, they offer automatic scaling and are cost-effective for event-driven, fluctuating workloads like voice command processing. Option D, They are primarily used for managing the knowledge base, not the back-end logic. The correct answer is they offer automatic scaling and are cost-effective for event-driven, fluctuating workloads like voice command processing. Here's the explanation. The exam tips section states, scalability and serverless. Voice assistant backends are often implemented using serverless functions due to their event-driven nature and automatic scaling capabilities, which are ideal for handling fluctuating voice command traffic. Question 9. How do voice assistants primarily interact with Internet of Things, IoT, devices in a smart home environment? Option A. By directly embedding their ASR and TTS components into each IoT device. Option B. By leveraging cloud IoT platforms to connect, manage, and securely communicate commands to devices. Option C. By using edge computing exclusively to process all commands without cloud involvement. Option D. By requiring IoT devices to have their own built-in NLP engines. The correct answer is by leveraging cloud IoT platforms to connect, manage, and securely communicate commands to devices. Here's the explanation. The Comparison-Related Concepts section under Internet of Things, IoT, explains, voice assistants frequently serve as the intuitive human interface for controlling IoT devices. They rely on IoT platforms like AWS IoT Core or Azure IoT Hub to connect, manage, and securely communicate with smart devices. Thanks for watching. Please subscribe to my channel.